So what is it saying? That there is a certain chamber, that's a closed chamber, right? And you have air and you have, what else is there? What was there? I
Hydrogen.
just forgot. Yeah, hydrogen. H2 is there, and it is exploded and no heat is going out, right? Heat is not going out, right? So this is a adiabatic chamber, you can call it that way. Okay, now they have given you some CV values, we'll look into that later, and a delta H value, and they have given you that N2 and O2 by volume is so much. What is the maximum temperature which goes into the chamber? Okay, now let me just propose you some answers. Okay, I'll propose you at least 4 or 5 answers. Get the point? And you have to tell me what is wrong over there. One of them may be right also. Maybe the first one itself is right. Okay, but I'll propose all 4 without telling you which one is right and wrong. Is that okay?
Yes, sir.
Okay. And forget about what answers they have given anywhere on the internet here and there. Okay, forget about those things. They just do something and solve something. There is no guarantee. Most probably this question was must have been created in Kota by Bansal or somebody. Okay, I don't know the source, but look here. One is, I would say that your enthalpy is given, the reaction is H2 plus O2 gives H2O, right? Right? We can say H2 plus half O2. It is given that the total pressure is 1 atmosphere and volume is nothing. I mean, nothing of the volume is given to you. So, and it is given that the hydrogen gas and the theoretical amount of gas, meaning to say what? Hydrogen gas must be totally consuming whatever it can consume from the air, right? Right? Right, guys? Hydrogen gas and the theoretical amount of air, right? So if if O2 is half of anything, half X, half K, so I can just take half mole itself because volume, there is no constraint on volume. Where is that thing then? Yeah. So N2 will be like 4 times 20 into 4, right? Volumes are same as mole ratios, right? In any confined chamber, right? 20 and 80, right? So what we can say is N2 is your, say, 4 times that, so 2 moles. O2 is half mole and H2 is 1 mole. This is the initial gases given, a mixture of hydrogen and gas. Any doubt in this? You can say 2x, half x, 1x. It will just change the volume of the chamber. Any confusion with that?
No, sir.
So if you are doing a question, you'll rather go with straight numbers and not a factor. Factor will cancel, but you have to do your calculations fast. So don't go for a factor, right? At 25 degrees Celsius. So what else is given is, it is a 298 Kelvin, right? Okay. This reaction, your delta H is 800 calories. When it is given per mole, right? So it is, if I've written 1 over here, then so much is the number, right? Per mole of the product. You remember that, right? Right? In
Yes,
calories I
sir.
have written because this is in calories, that is in calories. Okay, so proposal number 1. A reaction has happened. The heat evolved is so much. Whatever is the heat evolved is going to change the internal energy of all the molecules, okay, of all the system. Understanding? This is a closed system, and a certain amount of heat is evolved, right? right? It had some gases in it. So what are the gases? This is the composition initially, right? What is the composition finally? I'll write the final also over here. 2 mole N2, this and this gone, right? And 1 mole
H2O gas.
H2O gas, right guys? So what I'll say is the heat evolved is 57800 calories is change in internal energy of this, because nothing is escaping outside, right? Right? Obviously this is a confined chamber and there is no work also being done. The balls are not expanding and all, right? That has gone into the change in internal energy. Internal energy formula I know is, let me write it over here. Right? NCVT is the internal energy formula. So delta U, I'll go very carefully because I know in chemistry N can change, T can change. If there's a vast range of temperature, then CV also changes. But that has never come, and we don't have to bother. We'll take CV as a constant. Okay. Here also they have not mentioned CV at what temperature. Is that clear? So final NCVT will be what? 1 mole of H2O. What is this? H2O ka CV? That's a 9.3. Right? What's the final temperature? That is what we want to find, T. Plus there is 2 moles of N2. What is N over there? What is the N? N ka kya hai? N2 ka 6.3. Final temperature. This is your final internal energy, right? Minus initial internal energy. Okay. There's less space. I'll just write it over here. Okay, guys. I'll write it over here. What is the initial internal energy? Initial internal energy was 2 moles of N2, 2 of N2. All are diatomic. So I can take all of them as 6.3, right? हेलो शायद अभी मैं क्लास ले रहा हूँ, बाद में कॉल करता हूँ, ठीक है? नहीं तो दीदी को कॉल कर देना, ठीक है? ओके okay guys, 2 moles of N2 and what did I say? There is 1 mole, half mole of O2, 6.3. You can check the net. If this is a certain value, no, the other two will be almost the same value. You know that, no? It depends on the degree of freedom, right?
Yes, sir.
Right? Okay. And then you have, so maybe in the question when they are saying what will be the maximum temperature approx, so maybe the CV value of the other two, only N2 is given, the other two is not given, and hence they are saying approx. Maybe that's the reason. Plus 1 mole of 6.3 into 298, right? This will give me a certain answer, right? Yeah. So you want other proposals also, or you want to comment on this? I'll not tell you what whether you are saying it right or wrong. This gives a certain answer. Can somebody do a quick calculation? I've not calculated the answer for sure. I've not calculated in all cases whether it is the right one or wrong one. I've just written the formula. So can anybody just do a quick one over here and give me the T? And don't start matching that I already know the answer and hence this cannot be and this and that. Forget about what they have written. Are you understanding what I'm saying? Guys?
Yes, sir.
Yeah, so everybody respond. What do you think? This is right or wrong? And the reason. Everybody. Only 12 of you are there. Everybody tell me.
So can I answer?
Who are you?
Atharva.
Okay. Who all wants to answer first? Tell me all the names. Or you want to listen to all 4 proposals?
Yes, sir. Can we listen to all 4, please?
Who is this?
Akhil.
Okay. Let me think. No, you give me a, okay. Akhil, yeah, others, whoever, Atharva, tell me why this is wrong or right.
So 57800 won't be the heat evolved. It'll just be the change in enthalpy of the system. And that's not the heat evolved in this case.
Okay, he's saying it is not the heat involved.
And
Okay,
also,
anybody else?
the half mole of O2 won't be there once the heat is evolved. So why would that heat up?
Which one?
The
I don't
half
know.
mole of O2,
I have
it
not
won't
put
be there.
half mole. I have not put half mole of O2. I have said before. Did you understand what I was saying?
Yeah, I think so.
Before the reaction, this was the internal energy, right?
Okay, yeah, it's not in the final one. I got it.
Yeah, yeah.
Yeah,
And
anyway, that's not the heat.
after heat, yeah. So this guy, he's saying that this is not the heat evolved. Okay, anybody else? Let's see. Anybody else? I'm not even sure I'll come up with 4 different variations or not, because day before yesterday I was sure I'll give you 4 variations. Anybody else? Nobody? Nobody? Okay, proposal number 2. This is sad when nobody has any comment. He's saying is this is not heat evolved. Are you sure? Okay, proposal number 2.
Sir,
Hmm.
so can I just say something about this?
Yeah, who are you?
Akhil.
Yeah, can tell me.
Sir, we've considered only initial and final cases, right?
Mm-hmm.
But the process is not instantaneous.
Yeah, so what?
So like if we say one set of molecules, right? So like one molecule of hydrogen, sorry, 2 molecules of hydrogen, 1 molecule of oxygen make 2 molecules of water. Some of the heat would be evolved, which could heat up the rest of the hydrogen inside also.
Hydrogen is gone. Yeah, then
So
let it
no, sir.
heat. Total energy is conserved. No, it can heat. It cannot heat. Ultimately, initially there was some temperature, and final there is some temperature. There's a constant final temperature. There was a constant initial temperature. What happens in between doesn't matter. Therefore, enthalpy was introduced so that you just depend on the state and not the work. Therefore, enthalpy said H is equal to U plus PV. All state like this, add so much is the pressure, so much is the volume, and just calculate. That is the enthalpy calculation. Okay. Anyways, what you are saying doesn't matter. This gave this back, and there was an equilibrium, and this happened, that happened. Nothing matters. Initially is so much, and finally is so much. Initial internal energy was so much, final internal energy is so much. उसमें तो मुझे क्या डाउट आ रहा है? I don't know. When it is heating, it is giving the heat back to this and back to this, and due to this it is reacting. Yes, but these are not even existent after the thing, so it cannot store some heat or something. Okay, anybody else has to say something?
Sir.
Yeah, ma'am.
So for the when you count the enthalpy, it's the enthalpy of formation is at like a standard temperature and stuff, right? So you're already taken into account the internal energy required to break the bonds. Like when you're breaking the bonds, because that's how you calculate enthalpy, right? The bond formation of OH in the right side and the bond breakage of H2 and half O2 on the left side. I'm saying once you do that, since it's standard for a particular temperature, won't you already be counting its internal energy then when you decide the bond energy?
Internal energy. I'm saying that, so you are saying this is not the change in internal energy. That is what you are trying to say, right?
Yeah.
Because this is not taking care of bond energy, right?
No, I said
Okay.
it's the internal energy of the oxygen and the hydrogen has already been taken care of in the when you're calculating enthalpy because you're subtracting bond energies.
I'm not understanding. Tell me again. In this, what is wrong? Yeah, tell me. Final
It's fine,
energy
sir.
is wrong.
No, I'll find a better way to phrase it.
No, tell me, it's okay. I'm not getting the point. I got some point that enthalpy is taking care of internal energy.
No, I'm saying that when you have to calculate enthalpy, you're calculating how much you're subtracting the energy released by the bond formation. You're subtracting the energy released by the bond formation from the energy it takes to break the bonds, correct? And like that energy you use to break the bonds, that value that will already be taken considering how much internal energy it has at that temperature, I'm assuming. So if that's already calculating, like if that's already taking into account the internal energy, that shouldn't be there in the expression.
No. Wrong. That is not, internal energy is not only the bond energy. This is the other part. Okay. Okay. The other thing is going by the definition of enthalpy. What is the definition of enthalpy? H is equal to U plus PV, right? Right, guys?
Yes, sir.
So
Yes, sir.
your delta H is equal to delta U plus delta PV. Okay. So if I write the delta U for this, then what is the delta U and delta PV? Anybody? कौन है?
So if we can assume that the reaction is happening at a constant temperature, then I can say delta PV. It'll be the
Why
change in
not?
moles of gas.
No, I want from initial 298
Yeah.
to final, say, some temperature 3000 4000 T.
Okay, but if the reaction happens at 298, then after the reaction happens, the temperature increases from 298 to the final T. If you think of it like that, then delta U will just be delta H minus delta NGRT when the reaction happens, which will be at 298.
Okay, okay, I'll come to that next slide. Okay, suppose I write this as delta H is equal to delta U delta P V. Delta U is equal to whatever I wrote in the previous slide. Okay. Whatever I wrote over here, this is your delta U, and I add a delta delta PV to that. Delta U plus delta PV. Delta PV is your, initially it was what? PV is equal to nRT. R value will be around 2, right? Right, guys? So N is 2 and 3 and 3.5. 3.5, and finally it is 3. 3 RT minus 3.5 R. R is 2, by the way. 298. This gives slight correction to the previous answer. By God, man. Hello. Yes. Okay, okay. You just message them, okay, and leave. Okay. Okay. Get the point? Delta U plus 3.3. This is your delta PV. Any doubt in this that this is your delta PV, by the way? Anybody? Anybody any doubt? This is the delta PV?
So delta PV is expanded, right, as a V into delta P plus P into delta V.
Yeah, why would I do that, man? Initial PV I know, final PV I know. Okay, good that you have mentioned it. For gross change, no. For gross change, P plus delta P into V plus delta V when subtracted from PV. This is your delta PV. This is your delta PV. This doesn't come equal to, or does it come equal to P delta V plus V delta P? Does it, by the way? Just asking.
Yeah, it does.
Hmm?
So only if delta P and delta V are small.
Yeah.
It doesn't come, no? Delta P, delta V is not accommodated in this, right? Get the
Yeah,
point?
I didn't accommodate delta P, delta V in this.
Yeah, so you may do this, but generally it is all in theory books. When you have this gross big temperature change and big pressure changes and all, no, then don't do that. Okay, get the point? So
Yeah,
it
I got
is
it.
generally when we are doing integration, and when we are doing, we know it's a slow process and quasi-static, and one to next, next to next it is going, and we are integrating, then obviously dp into dv gets removed. Okay.
Yes, sir.
So anyways, when I have a p into v value, why would I go for whatever you said? Okay. When I have that value fully, initial p, final p, is there any doubt this is delta PV? Anybody, any doubt that this is a delta PV? So what is the doubtful thing over here, guys? One is saying, Atharva is saying delta U and this. Huh? So Atharva, what is your proposal of delta U?
So this would be the case if while the reaction was happening, the temperature went from 298 to the final T. Then this is correct. Because after the entire reaction occurs, the delta H is 57800, right?
Okay.
But
So what he's saying is enthalpy of the reaction was never given. If the enthalpy of the reaction was given, then this is okay, all right. So what is given is enthalpy of the formation of H2O, right? So this number I cannot put. So in the first equation,
yeah,
he said that this is not the heat evolved. In the second one, he is saying that this is not the enthalpy of the, once I use the definition for enthalpy, he said this is not the enthalpy of the reaction. Okay. One can go more stringent and remove, if I'm using enthalpy of water, I can remove the N2 from this calculation. And that would have been my next proposal, that I don't include N2. If I don't include N2, this becomes how much? This becomes how much? I say, okay, H2O का ही दे रखा है, then what will be this number?
1,
1, right? This becomes 1, and this becomes how much?
1.5.
1.5, right? So if I get temperature through that, then what I have to do? Once I've got that temperature, it gets distributed to N2 also, and they become equalized, right? Then I'll do a so much of gas at that temperature and N2 at 298. When fused together, when they are mixed together, then the final temperature will be how much T dash. Again, NCV TT I can do, right? Right? Okay, so next one, Atharva, tell me what to do, what to write, which might be right.
so can I just like explain my way of doing it?
Yeah, you tell me equations, I'll write equations, and then you tell the reason of that equation.
Okay, so
Because if anyone is wrong, we will cancel that out. If it is right, we'll keep it. Okay, tell me.
okay, what I'm doing is doing the reaction at 298 Kelvin constant, making it happen really fast, and then finding the actual heat that goes out, letting it go out, and then giving it back.
Letting it go out of the chamber or what?
No, I mean, it's not actually going out, but I'm just doing the reaction at 298
Uh,
and then finding the heat that would go out if it was allowed to.
that is hypothetical. Okay, how much is the heat which is going out? Tell me what do I write? Tell me.
That would be the delta U. So delta H, which is what they've given,
Hmm.
equal to the heat that goes out plus
Heat.
the
QI, right?
delta U, but it's the same thing.
No, don't. You tell me what to write, okay? You cannot
Okay.
say it's the same thing. Delta U then?
Plus minus
Plus
half R into 298.
minus half. Okay.
And the delta U I get from this will be the heat that will go out if the reaction
What is this?
happens.
57800 or minus 57800?
It's minus.
Minus. Okay. Yeah. So
Yeah, so now if I calculate delta U from this would be the heat that would go out if it was allowed to, if the reaction happened at constant 298, but it's not allowed to.
why
So
would
I
this
can
be
imagine
heat?
that
Why would this be heat? Why are we defining delta U as heat?
because the volume is constant and no work is being done.
This is delta U of what? Then you are saying volume are constant and work
everything in the
not being
container.
done of after things. See, two things are happening. Okay, others,
But right now, with the reaction,
I'll ask him later. Others, he's saying this is the heat. Heat is so much minus so much. Is he
this is
right or
only when
wrong?
the reaction.
Yeah, okay. After this, what do you want to write?
Yeah, so this much heat is not allowed to go out. So then basically we're giving this much heat back to the mixture.
Yeah, then what happens?
And right now in the mixture, this is after the reaction has happened. So this much heat would have gone out when the reaction happened. But now we're giving it back and the reaction has happened. So right now there's only 2 moles of N2 left and 1 mole of H2O left.
2
And
moles
everything is
of
still at 298.
N2. Yeah, 2 moles of N2 and 1 mole of H2O. So what do I write? Tell me.
And right now both are still at 298 because I did the reaction at constant 298.
Yeah, okay.
Yeah, so the equation will be the magnitude of delta U, not actual delta U, will be equal to 2 into 6.3 plus 1 into 9.3 into 6.3
yeah
plus 1 into 9.3 into T minus 298, where T is the final temperature.
Yeah, okay. Yeah, do you agree, guys? Do you agree?
So, but how do we say each of the reactions is happening at 298?
There's only one reaction.
Each reaction means what each reaction?
No, like reactions happen on a molecular level, right? It's not like all the hydrogen combined with all the oxygen at the same time.
Oh my God, that is a theoretical thing given. No, they are what? They are giving you each molecule's temperature or what? What do you want to take? Like that, no question can be done.
No, sir, it's like a continuous process, right? It's not instantaneous. Or are we just assuming it's instantaneous?
It's like a combustion thing, right? So you can
Okay.
make it really fast.
Okay. What's your point? What do you want to say? What do you want to change in this?
No, I was just confused how we can take all the reactions at 298.
No, and suppose I give you the data in the question is enough to do whatever. Okay.
Okay, yeah,
Like
then that's the
that.
only assumption. Then that's the only way.
Like that in chemistry, you can't even do a single thermodynamic question. If you keep speaking like that, then nothing can be done. In fact, a temperature of a whole mixture is not the same temperature at any given time. So that's not how you can deal with it. Yeah, others, are you okay with this? That
So then I'm also okay with it. Like,
this is the heat given out. This is the heat given out. Guys?
Yes, it's fine, sir.
Yeah, why? Why are saying this is the heat given out?
So this accounts for all the energy, right? So it's fine.
What?
So it accounts for all the energy, right? So it's fine. There.
Sir,
By your mic is very bad. It accounts for all the energy. What all energy? Wrong. You're wrong.
sir,
Ah,
it's a closed rigid vessel, right? So in a closed rigid vessel, your volume won't change, so your work done will be zero. So delta Q becomes delta U in this case.
everybody is getting two things absolutely wrong, which is why this meeting is delta U becomes delta Q. One is reaction and one is after reaction. Physics and chemistry. If you don't see where the barrier is, you will get the answers wrong. Fortunately, answers are so near that you'll never, I mean, this will hardly make a difference to the whole answer. 298 half, kitna ye? 290, you add 298 to this and do the calculations, or without 298 to this, it is going to give you a similar kind of answer. Chemistry, physics. When you say work is not done and all, what do you mean by that, man? Q is equal to heat given is equal to delta U plus work, right? What you are talking about this over here? It says you give a certain amount of heat. If work is not done, what is that going to do? That is going to increase the internal energy, meaning to say what? The kinetic energy and other things of this, kinetic energy and rotational kinetic energy, right? Linear kinetic and rotational kinetic energy, it is going to increase. That is how you have those degree of freedoms, by the amount of how much linear movement and rotational movement it has got, right? Right?
Yes, sir.
Yeah.
In your chemistry, when we say that a certain process has happened at constant pressure or constant temperature and delta H is equal to delta Q, do we mean this? Do we mean this? No, we don't mean this. One second. H is equal to U plus PV. This is the definition. Okay. Nobody can do anything about the definition. Okay. Now suppose a reaction has happened and I'm talking about delta H. A reaction has happened, I'm talking about delta H, and suppose I say at constant pressure. Suppose I say at constant pressure. Then this P goes outside, right? Becomes a W. Becomes a W. Then I'm asking you what is the difference between this and this? Most of the places they will say delta Q was delta H at constant pressure. That is okay, but they are meaning something and you are meaning totally different, because this is a good question to explore the difference. Delta U in this case was what? Okay, first I'll just come back to this. Okay, let me just ask you one thing before anything. What is given to us? What is given to us? Unfortunately, heat of reaction was not given to us. Enthalpy of reaction was not given to us. What was given to us? Enthalpy of some reaction which you may utilize in this question or not, and which is what? Enthalpy of formation of H2O gas. Can somebody tell me what does it mean in a blasted way? What does it mean? What does it mean? Bolo, koi bhi bolo.
Means when we do this reaction at constant pressure and temperature, that much heat will be taken
Yeah,
in.
constant temperature and constant pressure. Okay, so what you can mean for H2O gas? What temperature and pressure? What temperature and pressure? Absolutely right. All of them in their standard states, right, guys? And formation means one has to form. So all of them, this has to be one, this has to be half. So this delta H has been given to you, right? Delta H of this reaction, which is totally happening at 298. Hence the first proposal was wrong, right? Because I just simply use this value for that reaction, which was never told. That was that 298 to T, I use that reaction. Okay, it will give me nearby right answers, but not the exact answer. Okay, so what do you mean by this? H2O gas at 298. What do you mean by that? at one pressure also, by the way. One pressure, one atmospheric pressure, right? Right? And 298 Kelvin, right? Do we have? No, we don't have, right? But we don't care. Like that, most of the formation values are theoretical values. Get the point? Are you understanding? We don't have to have a background knowledge of when does O2 condense and when it becomes gas and when it becomes liquid. Are you getting the point? So what has been given to us? It has been given to us that H2O becomes H2O gas at 298 and it evolves so much of heat. कितना है delta H इसका? Minus 57.8 kilocalories, right? Right? If I go by the definition of H is equal to U plus PV, then delta H is equal to delta U plus delta PV. Can you tell me the delta U and delta PV for this before and after reaction? Now it has been given that this is at 298, this is at 298, right? We can assume any volume because the PV calculation is going to come same. It is 1 mole and 1 atmospheric pressure. This final thing is at 1 atmospheric pressure and 1 mole, right? Right? Right?
Yes, sir.
Initial ones were at those. They were all at standard states. So can you tell me what is this calculation according to your logic? I'll write some crap or I may write it right. Okay. Just tell me it is right or wrong. PV delta PV. Final one is PV. I read it as PV is equal to nRT. Right? N is 1, final is 1, R is 2, T is 298, minus initial is 1.5, R T, okay, okay. This is your delta PV. Delta U, N CV dt. N is 1, CV is 9.3, and final T is what? Sorry, NCVT whole delta. So final T is 298. And initial is what? 1.5 into 6.3 into 298. This is your delta CV. Yeah, what's wrong, what's right? What's wrong, what's right? I think this is an absolute calculation and we can get an answer, right? Forget about that 57 value given to us. Yes, what do you think, guys? At least I can see it is giving me a negative value. What do you think? This is all wrong or all right, or what is it? Say something.
So yeah, the second term should be delta and RT only because the T is constant and PV.
Yeah, this is 298, huh? Yeah, this is 298. So 1 minus 1.5 is a half. So what is wrong in this?
We're not writing delta U anywhere. You're just writing U. That doesn't make sense, right?
This is delta U, no? Initial U minus final U. Final U minus initial U. Final U is 1 into 9.3 NCV T 298. That's the final internal energy, no?
Okay, yeah.
So that's a delta U. This is delta PV. What's wrong in this? This is absolutely bull crap, by the way. This is the thing, what is wrong in Atharva's proposal of the first part, that we are taking the Q as that. And this wrong, whatever is wrong over here is a very minute wrong. So it doesn't make a big difference in the answer. So what is wrong in this? One student has already told what is wrong in this, by the way. And if you do this calculation, just look at the calculation, how small they are. They are not even going to reach this 57,000 and all. ऐसे तो हमको ये वैल्यू का जरूरत ही नहीं पड़ेगा. ऐसे तो like this, any gas of this kind of a A2 plus half B2 gives a 1C, a polyatomic one, okay, 3 molecules one or 4 5 molecules one. Any reaction of this kind, all will have the same delta H. Obviously that is bull crap, right? Right?
Yes,
Because the
sir.
delta H is basically dependent on the bond energies, right? So when you say very easily that, so this part is wrong. This part is so much, yes, so much of your kinetic energy, the physics energy change so much, plus how much ever potential energy of the bond. Get the point? And that will make the main bulk 50,000 or whatever. समझ में आ रहा है?
Yes, sir.
Get the point? The velocities of the molecules, whether it has become a diatomic to a single monoatomic, at a given temperature is hardly going to make a difference. Therefore, that delta H at a constant pressure, they are always like, they are writing a certain term and it is always working all right, because this part doesn't make a big difference. So जहां पे CV करके delta U लिखा हुआ है, where a chemical reaction is going on, you cannot use that. Okay, this is the one major point I wanted to clarify in the class. Delta U is not equal to NCV T while in a reaction. Before the reaction happens, this happens. At a reaction, it is all about bond energy and a bit of this also plus bond energy. After the reaction, again it will happen. Is that clear? Are you understanding? Otherwise, we'll have a concrete calculation for this, which is wrong. In fact, from here we can actually calculate that how much must have been the bond energy, all bonds taken together, because we are accommodating what? Due to the shape of the molecules changing, what is the energy difference, even though at same temperature? That is what we are accommodating over here. Is that clear? Is that clear?
Yes, sir.
So,
Yes, sir.
coming back to this, what do I mean by what do I mean by this? Since only this is given to us, then we'll go by that. H2 plus half O2 plus H2O gas, all gas at 298. So we'll assume that this reaction has happened. Get the point? In that chamber, all H2 converted to 298 H2O. All H2 and O2 converted to that 298 H2O. After it converted, then what happens? After it converted, then what happens? Then that heat which is evolved is distributed to everything. Is that clear? Is that clear?
Yes, sir.
So the delta H which is there, the delta H which is there will be the total heat and not minus a half RT. Okay. So what we'll take this as, that enthalpy which is given to us, we'll take it as the heat given out by a certain reaction, because it is all, this is the theoretical that it happened at a constant pressure and this and that, and it tells that if that happened, then at that pressure it gave so much of heat, and we'll have to take it. We have to take it like that, that all of a sudden we received so much of heat at the same temperature and the pressure remaining same. Fortunately, the vessel pressure was 1 atmosphere. It is all theoretical. Get the point? Are you understanding? So somebody
So
is
you're
not
saying
knowing
pressure
the
is
those who are not knowing those who are not knowing delta n and skip everything and doesn't know any theory, he may get the answer right. I'll repeat what this equation, what this term means. It means the reaction gives out a heat of, it means a heat. It directly means a heat. Why? Because it is made for your constant pressure thing. You know the point? This value is given for a constant pressure thing. It means that the reaction is giving out 57800. By the way, if you put in any formula, na plus minus का भी बहुत चक्कर हो जाएगा. If you put in a formula, nothing is going to work if you put in a formula because you'll have to write a minus. 57800 calories is the heat given out by this reaction when it happens at 1 atmospheric pressure and at 298, and the vessel was already at 1 atmospheric pressure and 298. So we'll assume that somehow that H2 and O2 converted to H2O, and now that H2O is also at 298 and 1 atmospheric pressure. So now the vessel has got H2O 1 mole, N2 is already there. At 298 this has, because the reaction says so, and fortunately we have 298 around us. So 298 and 1 atmosphere, it was already at this everything, this vessel was at 1 atmosphere. Now it is a heat, and now comes the physics question. Now it is an adiabatic process, and the physics question that a Q heat is, I mean, so much of heat is given to you and the heat cannot go outside. So there is no work done. There's no work done. And the heat cannot go outside. So isko tum adiabatic process bolo ya kya bolo, I don't care. The heat has to go into this. You know the point? So once you are sure that, okay, this much of heat you have received, 57800, then it is equal to what? The initial is H2O at 298. It is already H2O. Now it is post-reaction, whatever formula we are applying, post-reaction. So it is H2O at 298, which is like 1 into 9.3 into 298. This is H2O at 298. N2 is 2 into 6.3 at 298. This is the initial energies, internal energy, and the final internal energy will be both of them at 9.3 plus 2 into 6.3 at the final temperature. Get the point? So if you don't know any theory, still you might be doing this straight away. Get the point?
so
And not doing, you might not do, which is more close to change of the thing, which was the first frame. What was the first frame? I am taking, so when will you do this? This was the nearest answer. When will you do this rather than that? When it is, the same thing is being said, that it is enthalpy of the reaction. Meaning to say they are talking about temperature from there to there. Are you understanding? You ask what you are asking.
so but how did this reaction happen at constant 1 atm? It didn't,
Yeah,
right?
that, I mean, you don't have to care how it happened, no, because this how, therefore I made a frame. Therefore I made a frame that what do you mean by, it's gone. What do you mean by this value? So you can go and read text and all, don't have to, it is going to waste your time. It is simply that this doesn't happen. So there is no question of how. ये theoretically ये लोग निकालते हैं. They will calculate all this using theory, using graphs, by extrapolation of graphs. How
Okay.
can steam exist at 1 atm and 298 was my first question. Then what Akhil was saying, that if there is molecule, this will have, this will go there, this will go there. Obviously, that is also right. Get the point? Can steam exist at this? So forget about having the reaction. We don't have steam at that, because steam at 298, आपको प्रेशर उसको कम करना पड़ेगा अगर आपको 298 पे एक तो स्टीम चाहिए तो, ठीक है. So again, that is also, we don't have to care about this also. This information, this is the main thing why I'm taking this class. This information means that this got converted to this at the same temperature and pressure. Are you understanding? Then only this F word can be there. Delta F standard also they should have written of formation. Are you getting the point? Is that clear?
Yeah.
Yeah, okay. Okay, then that's it. So Meda was rightly telling in the initial frame, but that it is internal energy, but she said it is all of internal energy. It is not all of internal energy, and that has been taken care in delta H. No, it is not. It is internal, and it is all the different kinds of energy. Mostly we know of bond energies, and we know of if you go and read the papers and all, no, in bond energies also they will discriminate between the electrostatic and the mass energy, mass loss energy and all those things, but we don't have to care. This delta H is for us all that chemical energy, you can say chemistry wala energy, which physics cannot find out, and the physics wala energy, which is your NCVT. This is the physics wala energy. Get the point? So we know that a lot of formulas have been made just by ignoring this and that. But when a question comes, you'll have to do it from the actuals. You cannot refer to those formulas if it is not applicable. Okay. And another thing which I always try to make clear, because there was one question I think Mrigang or somebody was asking long back. PV, you have to go by this basic formula. Delta of this, delta of this, delta of this. Okay. Delta of the whole thing. ठीक है. क्या उसमें मेन चीज क्या था उसमें? एंथैल्पी. Okay, I forgot. That was also a very core concept was getting touched. Okay, if you have any doubts, stay back. Otherwise, go away. I'll take another session for all the pending things I had. Now I've got some time, so maybe this week I'll call you for a session. Okay, guys, this is the time you can actually beat the competition, because everybody doesn't have the motivation to study. If you show the motivation to study, if you imagine yourself to be sitting in IIT Bombay or IIT Delhi or IIT Chennai, if you can imagine that, then you will slog. If you don't imagine that, then obviously you will be doing a 5 or 6 hours a day. That means, okay, I have already achieved so much. Let's see if IT happens or not. I can write and give, IT will not happen. Let's see it will happen or not. It will not. On a regular, on a daily basis, you'll have to do, because of the competition, because the others will be doing it and you have to be better than those. Golden opportunity, whatever things you could not cover, you have to cover. Golden opportunity to work on the chemistry part, because that is what is going to give you a better rank. Maths, you be in touch, but it doesn't bring that much of a difference, because everybody does, every good student does almost the same thing. Get the point? But chemistry, and the ones who don't have a knack for maths, again, it is not going to develop in 1 month. So your mehnat in maths is not going to give you that much of a difference. What is going to come through chemistry and physics, you have to ace it. If physics, you don't know a certain concept, go and practice and practice and practice, and don't lose marks in chemistry and physics. Get the point? So Physical chemistry, lot of theory is there. Advanced will test your theories. So where physical chemistry is one of the easiest till mains level, becomes the most difficult in advanced level. So be careful over there. So chemistry पे dedicated time रखो, every day को time रखो, and if you have only 5-6 hours of study, obviously it cannot, you won't be able to cover it up. Inorganic, you have to be in touch always. If you have VK Jaswal or any other book, if you have completed one, start doing the other. There's endless work. Previous year questions, हर एक चीज का touch में रहो, because at least previous year, last 40 or 44, whatever it has become, that every competition guy is knowing it. If you are not knowing and something from there has come, then you are at a clear disadvantage. Okay, and then doing new fancy books and something matches over there, that is a hit and trial thing that may happen. But some books are like everybody is doing it and you have not done, then it would be not good. So previous year is something which anytime, any day, it should be on your fingertips, like the whole theory, why it was. जैसे लोकस वाले क्वेश्चन कितना बार वही पैराबोला सर्कल वही वेरिएशन करके दूसरा बना के दे देंगे. सो इफ यू हैव द थ्योरी विथ यू, यू विल बी एबल टू डू दैट. चलो, ओके. If you have to ask anything specific, you can ask, otherwise you can leave.
So can I send you one more question?
Yeah, send it tonight.
Okay.
Which chapter?
Thermo only.
Did you understand, Atharva, what is the difference I'm talking about? You think
Yeah.
a bit, okay? Think
Yeah.
over it, reflect over it. Okay. Okay, then bye-bye.
Thank you, sir.
Thank you, sir.
Thank you.